morning friends, this is RS Engineering and today we are going to have a lecture on moment of inertia part 2. So in the previous lecture we had seen center of gravity and centroid, and today we are going to have area moment of inertia or second moment of area. So what is this centroid? And to find the centroid of an area by the first moment of area about an axis was determined by sigma, that is some integral of x dA. The formula of centroid is integral of x dA. Now the integral of the second moment of area is called the moment of inertia, that is integral of x squared dA. That means we can say that the integral of second moment of area, that is x squared dA, is known as moment of inertia, and A is the total area and dA is the part of a whole area, just a part. Now by definition the moment of inertia of the differential area about x and y axis are dIxx and dIyy. So it is defined in two axes, one is x axis and one is y axis. See, this is y axis, this is x axis. So the formula for dIxx, that is for moment of inertia, integral of x squared dy squared dA, and for dIyy, integral of x squared dA. Now you think that seem to know that looks very hard to understand. So for this we are having a simpler in simple language. I have completed this one. So starting with this moment of inertia, what is the definition of a moment of inertia? It is defined as a sum of second moment of area of individual section about an axis. So what is this? Defined as the sum of second moment of area. Second moment of area is sum of an individual section about an axis, any axis. There are three axes actually there, x, y and z, but we are here only talking about x and y axis. So first of all we had to draw some few things. So let's draw first like this. This is the axis point. Okay, now we need some object. I think this is our object. Okay, this is our axis x, and this is x axis, this is y axis we are having here. Now for example we are having a part of this. Actually it is a complete area. Now here we are having a part and here we are having a part, and this one also a part we are having. So the distance between this one, what is this? This is y1, this is y2, and this is y3. Why are you taking that this is y3, y1 and y2? Because the distance from the x-axis, this x-axis line, distance from this to this points, this a part of the object is the distance, that is y3, y1 and y2 we had taken it. And similarly the distance from y-axis line to these objects are considered as x1, x2 and x3. Now let us take a1, a2 and a3 similar are the small elemental area of the total area A, that is this is the total area A, and this 1, 2, 3, these are the a1, a2, a3 which we had taken. Now few things after this thing we are going to have that taking moment about x-axis of all area ones. Now taking moment about x-axis of all the ones, that in a previous lecture we know that what is moment. Moment is actually the perpendicular distance. So the perpendicular distance into that area. Okay, that is actually we are having here, that is I, moment of inertia. The total area that is we are having, and the perpendicular distance from the axis we are having, that is known as moment. Now Ix is equals to a1 y1 plus a2 y2 and a3 y3. This is the first part, this is the second part, and this is the third part. Similarly, if we get it into the second integral, that means it is what? It is actually the second moment of area. It is the second moment of area, and now we are having integral on it. So the moment of inertia would be Ixx would be equals to I a1 y1 square plus a2 y2 square and plus a3 y3 square. That is the summation of a y square. This is the formula of moment of inertia about x axis. Okay, now getting to the second part, that is we had completed the x axis part. Now we are getting into y axis part. Okay, this is actually y axis. Okay. Now what is about y axis? It's like this, that similarly we are taking the same thing, the integral of second moment of area. We are getting it Iyy is equals to ay square. So these are the two formulas, this one and this one for x axis and this one for y axis. We are taking all this formula first for today only. This is our lecture. We'll get more parts like the radius of gyration, then we are having moment of inertia of some other planes, and the parallel axis theorem, parallel axis theorem, all those things in the next video. So for today, thank you.